In this video, we are going to look at empirical probability. So far, what we have been talking about is theoretical probability. Theoretical probability, which I will usually just refer to as probability, is what we will spend the majority of this chapter discussing. But there's also this notion of empirical probability, and so just so you understand the difference between the two, we're going to take a few minutes here to contrast them. So theoretical probability is the same definition as what I've already given, which is the number of ways an event could occur over the number of all possibilities. And the key word when we're dealing with theoretical probability is the idea of possibilities. We're counting possibilities and not what has actually occurred. When we're dealing with empirical probability, we are counting what has actually occurred in real life or in an experiment. So empirical probability would be the number of times an event occurred, past tense, this is something we've seen happen, divided by the number of times any outcome occurred. So let's say we're talking about flipping a coin. If I flip a coin once, and this is an exaggerated example, but if I flip a coin once and get a heads, then if I'm wanting the empirical probability of getting a heads based on flipping a coin once and getting a head, then the event occurred once out of one outcome, or 1. So it'd be 100%. Okay, now that's a bit exaggerated because you're not really getting a true sense of things just by doing something once. So let's say I flip a coin 10 times, and when I flip a coin 10 times, I get 7 heads and I get 3 tails. Now the empirical probability of getting a heads would be, it happens 7 times out of 10 flips, and so it would be 7/10. The theoretical probability is based on possibilities. So if you have a coin, how many possible head options are there? There's 1, and there's 2 total possibilities, so that's over 2, so it's 1/2. So that's the basic difference. The way you do it is exactly the same as far as building the fraction. It's just with theoretical probability, you're counting the possibility of such a thing happening. And with empirical probability, you're counting what actually happened in real life, or with an experiment, or like let's say you have survey results that come in and what people actually said in their survey results. That's the big difference. One of the important aspects, important mathematical properties about empirical probability is that the more times you perform the experiment, the more times you flip the coin, the more data you get, the more people you ask in your survey, then empirical probability will get closer and closer to theoretical probability. If, like I showed you here, if we flip the coin once, it's absurd. It's saying that getting a heads is 100% certain. That's a flawed experiment because we haven't done it enough times. If we do it 10 times we got 7 out of 10. Of course, I made that up. But assuming that it's a well-balanced coin, the more times you flip it, the closer that would get to a half. If you take a die, a 6-sided dice, and you roll it, theoretically you should get a 1/6 of the time. So the probability of getting a 1 on a dice is 1/6. Probability of getting a 2 is 1/6. When I'm saying probability there, it's theoretical probability. The probability of getting a 6 on a die is 1/6. Now, when I'm actually doing it in real life, that may not be the case for my empirical probability, but the more times I do it, the closer it should get to that 1/6 mark. So every outcome on a die should come very close to 1/6 after you roll the die 10,000 times, for example. This is actually the way you test to see if a die is weighted, or to see if it's a fair die. You just roll it a bunch of times, and if you get 6s, more than you get anything else, then that means the die is weighted to favor 6. Alright, we're not going to spend a lot of time emphasizing the difference between theoretical probability and empirical probability because the way you compute it is similar. It's just one is based on possibilities and one is based on actual outcomes in real life. But we're going to do an example here that kind of demonstrates what it might look like when you're doing an empirical probability problem. Okay, so here is an example based on a survey. 100 people were asked whether they use Facebook. The table breaks down the results based on age. What is the empirical probability that someone 18 to 25 uses Facebook? So in this case, even though they gave us all this other information, we're just looking at the age 18 to 25. So the probability that someone 18 to 25 uses Facebook. So that wording means we automatically narrow ourselves down to that category, and then the top of our empirical probability is the number of results that actually gave that event. So the number of people who use Facebook that are 18 to 25, that's going to be a 4. Okay, and the denominator is the total number of results, but in this case it's the total number of results for someone 18 to 25 because it asked about that specific group. So that would be at 37. It's a little tricky because it narrows it down to that group. So our event is, given that someone's 18 to 25, what's the probability that they use Facebook? So our empirical probability there is 4 out of 37. Now I do want to give the caveat that the fact that this is empirical probability is not always emphasized. So you could just as easily encounter this question as what is the probability that someone 18 to 25 uses Facebook? And it would be the exact same result, same question. The fact that it's empirical probability or theoretical probability is based on the context of the situation that's given, and then you just adapt what you're counting based on that. Usually it doesn't need to be emphasized. It's more, I think the emphasis of it may be more practical if, like, let's say you're wanting to determine the probability of a dice roll. Like, someone's telling you figure out the probability of a dice roll, and they say they want you to figure out empirical probability, which means you need to go run roll a bunch of dice to figure that out. Versus if they just ask you to figure out the probability theoretically. You may need to emphasize it if you're being asked to construct the study or just figure it out theoretically. But oftentimes, whether it's empirical or theoretical can be ascertained just based on context without actually using that word, and you'll see that play out a lot with these problems. Alright, go ahead and give some of these a try and see how you fare. If you have any questions, let me know.